Hello everyone, welcome to video lecture series on microcontrollers and applications. In this lecture, we will discuss pin diagram of 8051 microcontroller. Coming to learning outcomes of this lecture is, after completion of this lecture, you may be able to identify the pins of the 8051 microcontroller and their layout. Then you may be able to explain the functions of each pin and including input output pins and ports and control signals and power supply requirement for the 8051 microcontroller. And then you may be able to apply pin diagram knowledge to basic interfacing and embedded circuit design and embedded circuit applications. This is the 8051 microcontroller 40 pin configuration. If you observe here, it is having a 40 pins. You can identify the pin number 1 left side of this notch, or there is a one symbol is provided. From that symbol onwards, you need to count the numbers 1 to 20 like this, and then 21 to 40. And here the 8051 microcontroller is the one of the most popular and widely used 8-bit microcontroller in embedded systems. And it has 40 pin dual inline package. It is available here. So in dual on both sides of the IC, the pins are available. So that's why it is called as dual inline package. And each pin, if you observe the each pin of this IC has a specific function. This 40 pin is a VCC, 20 pin is ground. Some of the pins are provided for ports and some of the pins are provided for control signals. Each pin is having their own function. Understanding of this pin diagram is crucial for hardware interfacing and circuit design. So if you want to design any application, you need to make the connections, and that means you need to know each and every pin function to interface any device to 8051 microcontroller. Now let us discuss each and every pin, how it will behave, we will discuss. Okay. Now pin number 1 and pin number 2 is assigned for port 1. Port 1 is can be used as input or output port. That means it is a GPIO port. GPIO port is nothing but you can connect any input or output device to each pin of the port 1. Or if you want to use it for a single device as a 8-bit port, you can also use. That means you can individually program, or you can combinedly also you can program. This port does not require any pull-up registers. Why? Because it is already internally having a pull-up registers. Upon reset, port 1 is configured as input and ready to behave as a input port. But some cases you need to use this port lines as output ports. In that case, you need to configure by writing logic 0 onto corresponding port line. Okay. Once again, if you want to reconfigure it, then you need to send a logic 1 onto the corresponding port line. Then it will be acting as a input port. Based on our requirement, we can configure either by writing logic 1 or logic 0. So logic 0 means output, logic 0 means output, logic 1 means input. Based on your requirement, you can configure your port line. For output port, you need to write logic 0 for input port, but by default it is acting as a input port. But based on your requirement, you can also configure by writing logic 1 or logic 0. Then reset pin. It is a ninth pin. It is an active high pin. If the reset pin is high for a minimum of 2 machine cycles, the microcontroller will reset and terminate all internal activities. That means in order to activate reset pin, compulsory you need to provide a high level signal up to a period of 2 machine cycles. 2 machine cycles period, you need to provide a high level signal on reset input, RST input of your 8051 microcontroller. Then only your microcontroller will enter into reset mode and terminate all internal activities. Then during this time the oscillator must be running, and after reset all internal registers are cleared except stock pointer and ports. The stock pointer is having 07H after reset, and all ports are having FFH. That means port 0, port 1, port 2 and port 3. These are the 4 ports are available. So these ports are having FFH and the stock pointer is having 07. So these are the uh, status of the processor after reset operation. First it will terminates all internal activities. Whatever it is doing, this is first operation. Second, and one more important thing, so while you are supplying this reset signal to 8051 microcontroller, the oscillator must be running. Why? Because it has to check whether the signal you are giving to 8051 microcontroller is at least 2 machine cycles period. So that's why the oscillator must be running, and after reset all internal registers, every register is cleared except the stock pointer and these ports. This is the status of the processor after reset input. Pin number 10 to 17 are assigned for port 3, and pin number 10 to 17 are also have some special functions or additional functions. First, we'll discuss port 3 operation, port operation. So, port 3 acts as a bidirectional input-output port with internal pull-up register. That means this does not require any external pull-up register to configure as an input or output port, to be used as an input or output port. And upon reset, port 3 is configured as input. That means it is readily utilized for input port. But whereas if you want to use any port line of port 3 as output, compulsory you need to write a logic 0. A logic 0 should be written onto the port if you want to use it as an output. Suppose after some time, if you want to again, already your program corresponding line as output port by writing logic 0. But after some time, if you are to reconfigure it as an input, then again you need to write logic 1. So from this, I can conclude that here. So suppose if you want to configure any port line as output, first you need to write logic 0 onto corresponding port line. Suppose if you want to reconfigure this corresponding port line as, let us consider port 3.0. Initially, by default, it is acting as an input. Okay, it is acting as a input. You are written a logic 0 to configure it as a output port. Okay, so that means now it is acting as a output port after writing logic 0. Suppose again, if you want to configure as input, you need to write logic 1. You need to write logic 1. So that means if you want to configure any port line as output, you need to write logic 0. Configure it as input, logic 1. But by default, every port line is acting as a input port only. Every port line is acting as a input port. But after that, based on your requirement, you can configure either output or input by writing logic 0 or logic 1. So logic 0 for to configure output, logic 1 for to configure input. So this is about default configuration of port and how to configure port line as input and output. Then we need to discuss additional functions of port 3. So what are the additional functions that are available? We'll see. So here you can see the additional functions are allocated for this pin numbers are, this is pin number 10, 11, 12, 13, 14, 15, 16 and 17. These are the 8 lines. So these 8 lines are having a special function. So what are the special functions we will see. So if you observe here, there are two pins are provided for serial communication. These two pins are provided for serial communication. One is for serial input, another one is for serial output. RxD. Here RxD stands for receive serial data pin. So that means receive serial data pin. So that means the 8051 microcontroller serially accept the data through this line. When you are operating in a serial communication mode, it will accept bit by bit information from the external connected device. Similarly, TXD transmit serial data. It will able to transmit the serial data to external connected device. So transmit serial data. These two pins are provided for serial communication in 8051 microcontroller. One of the important thing you need to remember here, when you are using the serial port, so the XL frequency you are connected to 8051 microcontroller should be 11.0592 megahertz only. So in order to support required baud rate or in order to generate proper communication, you need to provide this 11.0592 megahertz to the 8051 microcontroller as oscillator frequency, as crystal oscillator frequency. And then there are two external hardware interrupts are provided. They are named as external hardware interrupt 0, external hardware interrupt 1, INT0 and INT1. These two interrupts interrupt the CPU based on the requirement of the device. So let us consider, suppose for example, this is 8051 microcontroller. Okay. So any peripheral device is connected like this. Whenever this device requires the service of the CPU, it will interrupt the CPU with the help of these two, any one of the interrupts. Suppose for example, two interrupts are connected like this. One is for INT0, one is for INT1. So, but the CPU will respond to only one interrupt at a time. So that's why it follows the priority. This INT0 is having highest priority, this is having second priority. So whenever both interrupts are comes at the same time, so the processor first serves the device, first device, and then it will serve the second device. Why? Because INT0 is connected to first device, INT1 is connected to second device. So these are the two interrupts, external hardware interrupts. And similarly, we are also having two pins. These two pins are provided for counter operation. Actually, in 8051 microcontroller, there are two timers are available. Two timers are available. These can be programmed to operate as either counters, counters or timers. Okay. So when you are operating these timers in counter mode, so the counters requires the external inputs from the any sensor. So that means the count value will be incremented whenever any input is coming through this pin. So that means T0 and T1 are external input for the timers when they are operating in a counter mode. When they are operating in a counter mode. So that means this is timer 0 input pin, this is timer 1 input pin. So there are two timers are there. So that's why two external pins are provided as a input for the timers when they are operating in counter mode of operation. So remaining two pins are write bar and read bar. Actually, these are bars. These two are active low output pins. So these two pins are used to access the data from external data memory. External data memory. So external memory write signal, this is this one, and this is external uh, memory read signal. So when the 8051 want to read the data, it will assert logic 0 on RD bar signal. So which is connected to RD bar signal of the data memory. And similarly, write bar is equal to 0 means the 8051 microcontroller is writing the information onto external data memory. So these two are for external data memory access. So this is about port 3. Then pin number 89, 19 are provided for XTEL2 and XTEL1 pins. These two are crystal oscillator pins, and 8051 has on-chip oscillator but requires an external clock to run it. So that's why a quartz crystal oscillator is connected to XTEL1 pin and XTEL2 pins to provide the required oscillator frequency. The quartz crystal oscillator needs two capacitors of 30 picofarads, and this is the configuration connection. So here XTEL1, this is the quartz crystal. This one is the quartz crystal. So this crystal frequency should be in between 1 megahertz to 40 megahertz. Based on our requirement, we need to connect the crystal of required size. Okay, but when you are operating with the serial port of 8051 microcontroller, compulsory we need to use 11.0592 megahertz only. Megahertz only. And you can see the two capacitors are used here, each size 30 picofarads. Why? Because the controller in any digital circuit, it requires a constant time period for clock signal. So that means compulsory it has to generate on period as off period is same. So to generate constant frequency to the controller, so here we are used 30 picofarad capacitances. And this is when we are using crystal as a oscillator. Suppose in some applications you may also use some other oscillator. So whenever this crystal oscillator is not possible, now we will go with some external oscillator. When you are using any external oscillator, you can directly connect the output of the external oscillator to XTEL1 only. In this case, XTEL2 is not used. Okay, there are two methods to giving the clock pulses to 8051 microcontroller with the help of a quartz crystal Another one is any external oscillator. So most of the time we will use only quartz crystal oscillator. Why? Because which will provide the constant frequency. Constant frequency. So most of the microcontrollers will use only quartz crystal oscillator, and the crystal you need to choose based on your required frequency. And one of the important thing, so when you are operating with serial port, it should be 11.0592 megahertz only. Then pin number 20 is a ground to the 8051 microcontroller. It represents 0 volts and it is connected to negative terminal of the power supply. So you need to provide 0 volts onto the 20th pin. Then 21 to 28 pins. These are provided for port 2 in standalone mode, and in case of extended mode, it is operate as a for generating higher order address, that is from A8 to A15. So coming to port operation, these are bidirectional input or output pins, but with internal pull-up resistors. Whenever internal pull-up resistors are there, there is no need of external pull-up resistor. Upon reset, port is also configured as input and ready to behave as a input port only. So based on our requirement, either you can configure it as a input or output. But you know that already I mentioned for port 1 and port 3. Similarly, here also you can program as input or output by writing logic 0 or logic 1. Logic 0 for output, logic 1 for input. But by default, this port is also behaves as a input only. Based on a requirement, you can configure as either output or input, but by default, it is as a, acting as an input. In addition to acting as a IO port, the port 2 is also act as higher order address whenever external memory is accessed. So when you are accessing external memory, so the higher order address bus, that means A8 to A15. These lines are provided by pin number 21 to 28. Next, coming to pin number 29. So pin number 29 is a program store enable, which is used to enable the external program memory. So already we discussed while discussing the architecture of 8051. So you can see when it is using external program memory, that is ROM, the ROM is having read bar control signal. This read bar control signal is connected to PSEN bar of our 8051 microcontroller. So when it will assert, the 8051 microcontroller asserts logic 0 on the signal is representing that the 8051 microcontroller reading the data from external program memory. So the program store enable, the name itself program store enable. So to access external data, this pin should be equal to 0. So the 8051 automatically places logic 0 on port PSEN bar when it is reading the information from program memory, external program memory. Then pin number 30 is acting as ALE as well as PROG. ALE stands for address latch enable. PROG stands for programming pulse input, programming pulse input, programming pulse input. When it is operating in user mode, 8051 is operating in user mode, this pin is used as a ALE. When it is operating in a flash programming, this pin is acting as a programming pulse input. Programming pulse input. First, we will discuss ALE. So already we know that the 8051 is having time division multiplexed lower order address and data bus. Okay, AD0 to AD7. So, but the in extended mode, the 8051 requires separate address and A0 to A7 and D0 to D7. Okay, separate buses are required. But actually, the 8051 is providing time division multiplexing. So, in order to differentiate this or demultiplex this, ALE is used. If ALE is equal to 1 is nothing but the 8051 is providing address information. So, if ALE is equal to 1. If ALE is equal to 0, means the 8051 is generating the D0 to D7. So, that's why in this way, the 8051 microcontroller differentiate or demultiplex address and data bus. And during flash programming, the same pin can be acting as a programming pulse input. Programming pulse input. So this programming pulse input gives the required clock signal for the flash programming. While programming the IC, while uploading the code into your IC, so the clock pulse is provided through this input only. And this input specifies at what rate you are uploading your code. Okay, so this is the operation of prog input under flash programming. Similarly, the pin number 31 is used as a EA bar and VPP. EA bar stands for here external access, VPP stands for programming enable voltage. Here also, in user mode it is acting as a EA bar, in programmer mode it is acting as a VPP. So first we will see external access. External access enable pin allows the external program memory. That means the 8051 microcontroller uses only external memory when it is connected to logic 0. EA bar is connected to logic 0 means the 8051 is using the external memory only. But whenever EA bar signal is connected having logic 1 means it is connected to 5 volts, then the 8051 uses internal memory as well as plus external memory. Whenever uh, it is connected to logic 1, first it utilizes the internal memory, then it is also utilize the external memory. But in case of external EA bar is equal to 0, it completely using only external memory. Okay. VPP. So this VPP pin, if you observe here, VP pin is equal to 0. Sorry. During flash programming, VP pin provides the 12 volts programming enable voltage to the 8051 microcontroller. So flash programming requires more amount of power supply. So that's why VPP is with the help of VPP input, we can provide the 12 volts to the 8051 microcontroller. Next, the pin number 32 to 39 is assigned for port 0. In addition to this, the port 0 is also the pin number 32 to 39 are also acting as time division multiplex address and data bus AD0 to AD7. Here, these lines are first we will see the port 0 operation. The port 0 is having 8 IO lines. These IO lines are behave as a input output pins, input output pins without any pull up resistors. This is the one of the important thing we need to note down here. The port 0 does not have any internal pull up resistor. But whereas remaining ports, we discussed port 1, port 2 and port 3. They are having internally pull-up resistors, but this port does not have any internal pull-up resistor. That means externally you need to connect pull-up resistors of size 10 kilo ohms to use port 0 pins as IO port. This is because port 0 is an open drain device. That means the drain of not connected to anything, it is open. So unlike in port 1 and port 2 and port 3. So that means externally we need to connect a 10 kilo ohm resistor as a pull-up resistor. And this is the configuration how we need to connect a pull-up resistor to each and every port line. Here you can see port 0.0 is connected to a 10 kilo ohm resistor. This is tied to VCC. Similarly, all lines are connected to 10 kilo ohm resistor. Then only this port 0 is utilized as a general purpose IO, GPIO. Then only it will be used as a general purpose IO. So once it is connected, then this port is acting as a, by default it is, this is also acting as a input port. This is also acting as a input port only. Now that is nothing but it is ready to behave as a input. But while developing any application, you require this port is also used as a output. So that in that case, simply you can write logic 0 to program any line, any one of the line of this port as output. Suppose if you want to reconfigure again it as input, you need to write logic 1 for input. So to make output any port line as output, logic 0. To configure any port line as input, write logic 1. But by default it is acting as a input port only. Okay. Then next the 40th pin is the power supply pin on which you need to supply. It is a input 5 volt DC. So these are the 40 pin IC configuration of 8051 pins, and in this session we explored the 40 pin configuration of 8051 microcontroller, and we learned about the parallel ports, port 0, port 1, port 3. The 4 ports are available. They are acting as a ports, and they are also having dual functions. And one of the important thing here we need to note down, port 0 does not having any pull-up registers. So that means external pull-up registers are needed when it is used as a GPIO. But in case of port 1, port 3, port 1, port 2, port 3, internally there is a pull-up registers. So that means it does not require pull-up register for port 1, port 2, port 3. And every port is having their dual functions. So port 0 is having time division multiplexed address and data bus, and port 2 is having higher order address bus generation, and port 3 is having alternate function. And we are also explored on VCC and ground. So VCC required for 8051 is 5 volts, ground pin is 0 volts. There are two different types of uh, clock input we can provide to 8051 through these two pins, XL1 and XL2. One is quartz crystal oscillator, another one is any other oscillator. Normally we will prefer only quartz crystal oscillator. We are also discuss reset pin and its role in system initialization. So already you know that in order to reset the 8051 microcontroller, a high level signal must be provided for 2 machine cycles period. And one more important thing, So while giving this reset, the oscillator must be running. The oscillator must be running. So once the valid reset signal is available on reset input pin, so then it is enters into reset state. So that means it terminates all internal activities, it clears all internal registers, and then except the stock pointer and ports. Then control pins like EA bar, PSCN bar, program store enable, ALE we discussed. EA bar is for whether you are using complete external memory or internal memory plus external memory. So the program store enable is used to access the external program memory only, and ALE is used to demultiplex the address and data bus. Okay. So next class we will explore how 8051 microcontroller organizes its memory, including program memory organization, data memory organization, some special registers we will discuss. Thank you for patient listening. Thank you all.